Hello and welcome back to Pre-Algebra with Miss Betsy. Today we are continuing to work with equations, and we're going to see how we use the distributive, the associative, and the commutative properties to manipulate our equations so that we are able to come up with a single value for the variable that gives us a true expression. If you're using my text, what I have is Pre-Algebra for Christian Schools. It's published by Bob Jones University Press. I'm using the first edition. This is Chapter 8, Section 5, and I'm on page 263. Before we get started, can you tell me what it is that the King Kong said when his sister had a baby? King Kong said, "Well, I'll be a monkey's uncle." And yes, I know that's lame, but that's what I live for, is these lame jokes. Let me go ahead and take this expression here. I have 7 times the quantity x plus 3 plus 5x. Now before we actually work with some equations, we're just going to take this expression here, and what if I said, let's simplify this? Well, in order to simplify, you have to be able to collect like terms, don't you? Well, what do we have going on here? 7 times the quantity x plus 3 plus 5x. What I see right here, I'm going to need to distribute, so I'm going to use the distributive property. And when I use the distributive property, I have a marker getting out of ink, 7 times x plus 7 times 3 is 21 plus 5x. Now what can I do? Well, wouldn't necessarily have to do this, but I'm doing this strictly to illustrate that I can change the order around, which is the commutative property. As I change the order of these 3 addends, remember, are what you add together, what I'm going to do is reverse the order of the 21 and the 5x. Now I have 7x plus 5x plus 21. And I use the commutative property to do that. Now we also have the associative property that says you can group together in any way that you wish to. You can group any pair. So I'm going to go ahead and use the associative property that lets me pair together any 2 addends. So I have the associative property. And you remember that when you have like terms, the variables have to agree, the exponents have to agree, and when that's the case, what do? You simply add the coefficients together. 7 plus 5 is 12. We now have 12x plus 21. And we're finished with this problem. This is in simplified form. Okay? We distributed. We changed the order of our addends to put the like terms next to one another. We grouped those. We added the coefficients to get 12x. And we now have simplified form of our original expression. And there's nothing more that you can do to that. That's the simplified form. Now, in real life, when you're actually going through and solving a problem that looks like this, you're probably not going to be taking, you might use 3 of those steps and not 4, but it's very, very important for you to see how we track through this. And see that, I can look at this and I can say that this simplifies 12x plus 21. But what lets me get to the 12x by 21 is the distributive property, using the commutative property, using the associative property, and collecting like terms. So you see that there's a basis and a methodology and a rule. Everything that we're doing in algebra is based upon something that's come before. It's something that's already been defined. So let's go ahead and solve a couple of equations. This is example 1 on page 263, and I can't get the cap off my marker. Example 1, page 263. Solve and check. This says 7y plus 2 times the quantity y plus 4 is equal to 71. What are we going to do to solve this problem? We're going to look here and say, oh, we have the distributive property first that we need to apply. 7y plus 2 times y plus 2 times 4 is 8 is equal to 71. Now you see that we already have our y's next to one another, and that's just pointing out, illustrating, emphasizing to you that 7y and 2y are like terms. Because their variable is the same, we add the coefficients, and we have 9y plus 8 is equal to 71. In order to solve for y, we're isolating that variable by itself. So we see what's happened here. Well, first, it was multiplied by 9. Then 8 was added to that product. To undo this, we work in reverse order. They added 8. We're going to subtract 8 from both sides of the equation. Plus 8 minus 8, 71 minus 8. 9y is equal to 63. Y has been multiplied by 9. We're going to divide both sides of that equation by 9, and we see that y is equal to 7. Now how would we check this? We take that value of 7, plug it back into our original equation. Original is a new way to state something, isn't it? Let me back over here and let me show you my check. Seven times 7 plus 2 times 7 plus 4. Is that equal to 71? 7 times 7 is 49 plus 2 times 11. Is that equal to 71? 49 plus 22 is definitely equal to 71. So our value here of 7 for y is a correct solution to our original equation, which was 7y plus 2 times the quantity y plus 4 is equal to 71. This is all that you're going to be doing in this section, which is chapter 8, section 5. So let's go on to our next example. Top of page 264, it says, using the associative and commutative properties in combination, you can group 3 or more terms in any order. And example 2 says, let's go ahead and solve and check this problem. First we have 2 times the quantity, 3z minus 4, plus 2z plus 9 is equal to 65. As I said, after you've copied a problem down, make sure you take the time to go back. Make sure you've gotten it correct. 2 times quantity 3z minus 4 plus 2z plus 9 is 65. What's the first thing that you're going to do here? Yeah. Very, very frequently you're going to have to distribute something. 2 times 3z, that's 6z. Because you actually have 2 times 3z plus 2 times a negative 4 plus 2z plus 9 is equal to 65. Do you see what I did? 2 times 3z plus 2 times a negative 4, or if you have learned distributive property of multiplication over subtraction, this here could alternately be written 2 times 3z minus 2 times 4. I want you to pause the video, make sure that you understand these two expressions here have the identical meaning. When you distribute 2 times the quantity 3z minus 4, it's what they call the distributive property of multiplication in our pre-algebra book over subtraction. So 2 times 3z minus 2 times 4. We can also call that, there's also pierogies there if you want to fry them. We also can write this as addition, where we keep the sign in front of the 4, plus 2 times a negative 4. Continuing on this says 2 times 3 times z. 2 times 3 is 6z, plus 2 times negative 4 is a negative 8, plus 2z plus 9 is 65. We have no more multiplication to do. We have nothing to distribute. We need to collect like terms, and we can change the order of our addends by using the commutative property. Plus 2z plus a negative 8 plus 9 is equal to 65. When you have like terms, same variable, you add the coefficients. 8z plus negative 8 plus 9 is a positive 1, so it's plus 1, is equal to 65. I don't care what 8z plus 1 is. I want to find out what z by itself is. So I'm going to subtract a 1 from both sides of the equation because I am doing my best to isolate the variable. How did I know to subtract a 1? Well, I look over here on the left-hand side of the equation where the variable is, and I say, okay, what happened? If I started off with just 1z by itself, what happened? First, it was multiplied by 8. Then, 1 was added to that product. In order to undo that and get back to just a z by itself, you apply the inverse operations in reverse order. Sounds like a mouthful, but you know how to do this. But you also have to become accustomed to understanding the verbiage, if you will, of math. The inverse of addition is subtraction. So we subtracted a 1 from the left-hand side of the equation. We also subtract a 1 from the right-hand side of the equation, which keeps our equation balanced properly. Now we have 8z is equal to 64. Z has been multiplied by 8. The inverse operation for multiplication is division, so we're going to divide both sides of that equation by what value z was multiplied by, which is 8. 8 divided by 8 is 1, so we have z is equal to 8. I don't know about you, but it would have taken me a while to have come up with 8 for being the answer just by looking at something. So what you're seeing now is an illustration of why I wanted you to learn methods and properties. Way back here when you had a problem that said x plus 1 is equal to 4, you look at that and everybody knows, even if you've never heard of x, you would probably come up with, oh, well, if I put a 3 in there, it's correct. You can't take an equation that looks like this and arrive at the solution of 8 near as readily as you can arrive at a solution of 3, I'm sorry, over here. Now we need to check this. How do we check? You take this value here of 8, substitute in to the original equation. Make sure I stay in the picture. Here's my check. My problem, 2 times 3z minus 4 plus 2z plus 9 is equal to 65. I want to take that value where we see that z is equal to 8. Every place there's a z, I'm going to substitute in that value of 8. Minus 4 plus 2 times 8 plus 9 is equal to 65. I used brackets so that I could show my substitution in here. 2 times 24 minus 4 plus 16 plus 9. Does that equal 65? We should really put a question mark on top of all of those signs because we don't know if that's true. This is what we're determining if it's true. 2 times 20 plus 16 plus 9 is 25 plus 25. Is that equal to 65? 40 plus 25, of course, is equal to 65. So we have now checked our solution of 8 for our answer to this equation up here. Come up with a true statement so we know that our value here is correct. Go ahead and take your time on these. I think you'll enjoy them. They're very straightforward. You make sure to take the time to perform your check, and you won't miss problems on your homework. You won't miss problems on your tests, because when you do happen to get a wrong answer over here, by the time you try and check it, it doesn't work. Enjoy playing around with these. I'll see you next time.